Welcome back, guys. Bismillah Rahman Rahim. Okay, so in the previous video, I explained why why decanting can't be done on suspensions. What is suspension and what is decanting? We've covered already in the previous lectures. Now let's talk about the technique by which filtration is actually done. Okay, so let's move on. Okay, so what is a precipitate? First, let's look at these two definitions. Precipitate refers to an insoluble solid particle in a liquid. It can be any solid particle, it can be localized, it can be spread throughout the liquid. Okay, but any solid which is present in a solution is called a precipitate. What is a suspension? Suspension is that solution on which we cannot do decanting to separate out the liquid from the solid or the solid from the liquid. So what is suspension? It is a mixture where solid particles are found throughout the liquid, okay? I'm sure I've repeated this definition so many times that you might have now memorized it. But anyways, now these are the three test tubes that I've shown over here. And each of these test tubes show different solutions. Okay, this is how a clear solution looks like without a precipitate. Okay, the first one, the blue solution. No precipitate present, meaning no solid present. Over here in the second solution, we've got solid particles present throughout the liquid, or throughout the solution, or throughout the mixture. We've got solid particles. So this type of mixture is called a suspension. And over here in the third one, is the test tube where we can use decanting. Okay, decanting is a technique in which a localized precipitate is present. The liquid can be removed from that solution. Okay, localized precipitate would settle down at the base. It would be denser and it would be insoluble, so it would settle out down at the base, and then the liquid on top can be removed out into another container. Okay, these are the three test tubes. Now quickly let's move on to the technique by which filtration is done. So we are going to do filtration on which type of solution? We're going to do filtration on suspensions. Okay, now let's move on. Okay, so here is our experiment 2. Remember, we gave the reference of experiment 2 just a bit. I think you can't see it fully. Okay, now I hope you can see it fully. Yes, you can. Okay, now this is experiment 2. Okay, now in this experiment 2, we've got scenario over here, basically a mixture or that same reaction that we talked about in the previous video, sodium sulfate and lead nitrate. Sodium sulfate, when it reacts with lead nitrate, PbNO3 2, it will form what? It will form sodium nitrate and lead sulfate, PbSO4. And let's balance this out as well. And yeah, it's balanced now. This is our white precipitate solid that has formed, and we need to now remove out this solid from the mixture solution. Okay, and the technique that we are going to use is called filtration, and filtration is the most common technique for such solids that are formed, or such precipitates which are formed in a solution. Okay, right, guys, so the procedure, let's look at the procedure in a bit detail now. Okay, the very first thing that they did was they prepared the lead sulfate solution, or prepare a mixture of lead sulfate along with the liquid in which it was immersed. Okay, and by the same technique, they used lead sulfate and lead nitrate, sodium sulfate and lead nitrate, and mixed them, and as a result they got lead sulfate solution, and in which lead sulfate was the precipitate. Okay, so 30 cm of sodium sulfate and 50 cm, well, you don't need to know about the volumes, you don't need to think much about the volume, you just take two solutions and just mix them out. Okay, and after mixing you get a solution containing lead sulfate and sodium nitrate solution. Then the second thing that you do is you take the filter paper. You will definitely get a circular sheet of filter paper, which I don't have with me right now, but you definitely have it in your school labs. And what you do is you make a semicircle of that, and then you make a cone shape over here. But since you are in O levels, you don't need to get into all that. Okay, nobody is gonna ask you to make a cone out of a filter paper and stuff. Okay, it's all in A levels that you'll need to do. Okay, over here it's ATP. So you just simply need to know how it's made. It's just a cone that is made. You place the cone in the filter funnel. Okay, this is called a filter funnel right over here. And in the filter funnel, oh, just a sec. Okay, now collect, okay, you've placed a filter funnel. And now the third step is right over here, this one. Okay, let me zoom in over here. Okay, this is the third step, in which you take the mixture which contains lead sulfate, precipitate, and the sodium nitrate solution, basically the suspension. You take that and you pour it onto the filter paper, which is lined, which is lining this filter funnel. Okay, this is a funnel over here. This Y-shaped apparatus is called a funnel, a glass funnel basically. And in the glass funnel, you line the glass funnel with a filter paper. And on that filter paper, you add in this suspension. As soon as you add in this mixture on the filter paper, what happens? The liquid, it passes through the filter paper, because the filter paper is acting as a sieve now. It's acting as a SEIEVE, I think. Well, I'm not sure about the spelling, but check out the spelling, but it's acting as a sieve, which we call in Urdu channi. Channi, chai ki channi jo hoti hai. ठीक है? Sieve, it acts as a sieve which has small holes that allows the liquid to pass but prevents the solids from passing. So it acts as a selectively permeable membrane. Okay, and from this membrane, this reaction mixture, the solid in the reaction mixture is left on the filter paper. The solid which is left on the filter paper has a special name called residue, and this is important now. Okay, this residue over here, this is important. What is residue? The solid which is left on the filter paper after this filtration process is called a residue, whereas the liquid that passes through the filter paper and the filter funnel into the conical flask, that's called a filtrate. Okay, so remember, you have to use a conical flask for filtration, on which you place a conical funnel, and the conical funnel sits on the conical flask, and in the funnel you place in the filter paper, and in that you add in this mixture. The solid is left as a residue and the filtrate passes out. Okay, the filtrate of course is not going to be that pure, but this solid might also not be that pure. So what can we do? But this is actually the ultimate procedure of filtration. Okay, that's it, nothing else. So what do you need for filtration? I'll just quickly list it down here. You need a filter paper, of course. You need a filter funnel. You need a conical flask. Okay, this conical flask down here, conical flask. And finally, you need that mixture from which you are actually filtering. And then what do you get as a result of filtration? You get the residue left on the paper, and you get the filtrate in the conical flask. I hope that's clear. After this, you can, if you want to purify the residue further, then there's another step that you can do. And let me just go over here, zoom out a bit. Okay, now this last step that they have done is, it's called washing with distilled water. This has been done so as to remove any traces of the filtrate from the residue. Okay, even if a small amount of filtrate was left on the residue, it would be washed away by the distilled water. Okay, and then after pouring the distilled water, the residue, it's gonna be wet, right? It's not gonna be dry, it's gonna be wet. So what are you gonna do? You're gonna place a few sheets of filter paper on top and beneath the residue, the wet residue, and it will dry out by filter sheets. Or there's a second way, is just heat it in an oven. Either you use an oven to heat it and dry it, or you could use additional sheets of dry filter paper to dry the residue, and you'll have your lead sulfate in no time. Okay, lead sulfate residue will be formed, but again, not very pure, but it's better than decanting. Okay, still better than decanting, because you will get actually your residue, okay, by filtration. This sums up filtration. If you have any questions, you can leave it down in the, okay, wait, we still have another sheet. Let's go through this paragraph as well, and then we'll wind up the lecture. Okay, just a sec. Okay, now this has been taken from the same book, Chemistry Matters. A solid can be separated from a liquid by filtration because the filter paper acts as a sieve. Remember, I told you about the sieve, channi. So it acts as a selectively permeable membrane. Liquid can pass through the pores, the small holes of the filter paper, but solid cannot do so. Okay, the solid won't pass, the solid would be left behind, but the liquid would pass out, as shown over here. Upon filtration, the solid that remains on the filter paper is the residue, and the liquid that passes is called a filtrate. Okay, and we've talked about both of them. A solid left is residue and the liquid passed is filtrate. Large insoluble particles are trapped by the filter paper and become the residue, and small particles of the liquid pass and become the filtrate. This is the filtrate, this is the residue, and that's the funnel, and that's the paper, and this is the beaker. And this actually sums up everything about filtration. The next thing that we are going to do, the next technique is a technique of second point, evaporation to dryness and crystallization, of course. What do I mean by second point? Well, if you look at these points, not solids, we are going to do this one, a liquid from a solution, solid from a liquid. Okay, wait, this is not the second point. This is the third technique, evaporation to dryness and crystallization. And these are the two techniques which we can use to get a bit purer substance as compared to the filtration, as compared to decanting. Okay, so we'll be talking about that in the next lecture. Stick around, guys, and see you next time.